So for my chemistry class, I know my head's going to get cut off here a little bit, but for your percent yield problems, I needed to go over this concept really quick. So I'm going to go over the idea, um, and then what I'm going to do is I'm going to work two problems for you before I cut you loose, okay? So here's the idea, guys. I'm going to scoot this in just a little bit, so maybe this is a little better. Sorry, I'm going to have to squat. So percent yield is the idea that when you do a chemical reaction, so far when I've been doing limiting reagent, or just saying, okay, how much can you make? We're assuming that you're 100% perfect. And in real life, that doesn't happen. When you do a chemical reaction, usually you're not 100% perfect. So the idea is to take a look and see how efficient your reaction is. How good are you? So percent yield is taking a look and saying, okay, how much do you actually make versus what's possible, and then multiply it by 100%. And it really is like a grade. So if you wanted to know what your grade in a class was, or what your grade on a test was, say you're taking a 50-point test, and you got 46 out of the 50 points. What's your percentage? It's a 92%. You take 46, divide it by 50, multiply it by 100, you get 92%. It's the same thing for a chemical reaction. If you figure out, okay, I should be able to make 50 grams of a product, and you do the process, and you wind up making 46 grams, oh, you made 46 out of a possible 50 grams, your reaction gave you 92% out of what's possible. And I want people to get comfortable with the idea of saying, look, when you do a chemical reaction, generally speaking, you don't get 100% yield. In fact, you don't even usually get that close. If you get something anywhere above 50, 60%, you're doing pretty good. Those of you who go on to take a lot of science classes, you do organic chemistry, you're going to be happy with things in the 10, 15, 20% range. So we need to tie this into something that we did a lot earlier in the year, and that's the law of conservation of mass. So when you do these problems for me, sometimes it's going to seem a little artificial and a little difficult because you're like, wait a minute, how much do I know that I made? In the problems that I give you, I'm giving you an amount that you made. If you were actually in a lab or working for a chemical company doing this, you would actually make something and measure it. So the first parts of these scenarios that I do for you, I'm going to say, hey, here's a chemical reaction, and you made so much in grams. The second part, though, is a stoich problem, and that's where these two things come together. You're going to make an amount, but then you have to see how much was actually possible to make. So sometimes it's just a normal stoichiometry problem saying, okay, how much could have you made? How much could have you made? God, my English is terrible today. How much did you make? What's the ratio? Sometimes it's a limiting reagent problem too, saying, hey, you've got two reactants. Which one's holding you back? Then based on which one's holding you back, how much could have you made? And then here's the amount that you did make. So there could be a lot of steps involved. So when you do percent yield, the top number, your numerator, is a lab amount. It's something that you actually have to measure, or in the problems, it's the number I give you. The bottom number, your denominator, that's something that you have to calculate. It's a stoichiometry number. Might be limiting reagent, might not be. You're going to have to do a little interpretation. The important thing is that you can't go over 100%. Law of conservation of mass tells us matter is just converted. So when you do a chemical reaction, all of your pieces have to balance, but you can't wind up with more stuff than you started with. So you can get a percent yield up to 100%. And if it's less than 100%, it doesn't mean that you did everything right. It just means that it's possible that you did everything right. But if you get a percent yield that's over 100%, you've got to do some digging because you're saying, wait a minute, something's wrong here. Maybe I did a math error. Maybe I calculated something wrong. Maybe in the lab, my scale was off. I measured something wrong. Maybe I've got contamination. Maybe my products are still wet and I need to dry them more. Maybe my reactants didn't react all the way and I'm weighing two things when I should be weighing one. All you know is that if you get a percent yield over 100%, you've got error analysis to do, and you've got to go back and say, hey, I might have done something wrong. What do I need to fix? So I'm going to work two example problems. One is a one-to-one and just a regular stoic problem. One as a limiting reagent problem. And then I'm going to have a couple of examples up for you online, other than just the problems you need to solve for this unit. And then the last thing that you're going to do this unit is I'm going to throw all concepts at you in a problem set. It could be just a stoic problem. It could be limiting reagent. It could just be percent yield. It could be two of those three mixed together. It could be all three. You're going to have to do the work to figure it out. Okay?